Hi everyone. In this video, I want to go through a few more examples of conditional probability, this time without the multiplication rule. So these are not two events happening one after another. Instead, we're going to have an experiment where we're rolling two dice one time, and we're just looking at the sum of the dice. So event A is rolling doubles. That's two of the same numbers. Event B is die 1 is going to have a value that's greater than 3, so that's 4, 5, or 6. And then event C is going to be that the sum of the dice is even. So we want to find the probability of A given B, the probability of B given A, the probability of A given C, the probability of C given B, and the probability of B given C. Now you'll notice that we have some that look similar. So we have the probability of A given B and the probability of B given A. That's not necessarily going to be the same probability. So let's go through these one at a time. And let's remember what the probability, let's first figure out what is the probability of A rolling doubles. Well, I have this chart from a previous assignment, and instead of a black and white, we're going to call this die 1, and we're going to call this die 2. Okay, so we can see that along this main diagonal here, we have all of our doubles. So there's 1, 2, 3, 4, 5, 6 doubles. There's 36 total numbers here. So probability of A is going to be 6 over 36. Okay. We can write that as 1 over 6 if we want, but it doesn't matter right now. Let's also find the probability of B. So that's the first die has a value that's greater than 3. So the first die has a value that's greater than 3. So that would be all of the values here, because die 1 has a greater value than 3, 4, 5, and 6. So there are 1, 2, 3, 4, 5, 6 in each row. There's 3 rows, so there's actually 18 values there. Okay, so that's 18 out of the 36. And we could call that 1/2, but let's just leave it 18 out of 36 right now. And then let's find the probability of C. And so the probability of C, the sum of the dice is even. So let's look at all the values here where the sum of the dice is even. So that would be anything where we're summing to 2, where we're summing to 4, where we're summing to 6, where we're summing to 8, where we're summing to 10, and 12. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 values here out of the 36. So this has the same probability of event B as well. All right. So now we're going to go ahead and find some of these conditional probabilities. And later on, we're going to talk about mutually exclusive events, and we're going to talk about independent events, and we're going to talk about dependent events. And so we're going to need to make these comparisons between the probability of A. I think we already talked about independent events. If we knew that these events were independent, the probability, for example, if A and B were independent, this would just be the probability of A. And if B and A were independent, this would just be the probability of B. Because if they're independent events, it doesn't matter if one happens and then the other one happens, because they're independent. So the event A has no bearing on event B if we're independent. Excuse me. So let's go ahead and find some of these probabilities. Let's start with finding the probability of A given B. So we're looking for the probability of rolling doubles if we already know that die 1 is more than 3. So what this does, what this condition does, is it actually makes it so the number of possible outcomes that I'm looking at has decreased. So the denominator of my fraction is now only consisting of these values because these are my givens. I know that the value of die 1 is greater than 3. Now let's find all the values within this where we roll doubles. So that's going to happen here, here, and here. So there are 18 values that I could have chosen from. That's my sample space is 18 values because I was given, I know that the value of die 1 is greater than 3. So I'm given that. And these are 3 values within that sample space that are favorable outcomes. So the probability is going to be 3 out of 18. 18 is all the values where die 1 is greater than 4, or greater than 3, sorry. And 3 is the number of doubles within that sample space. Now that is not equal to the probability of, is that equal to the probability of A? It is. So are these independent events? Are they dependent events? It seems like whether or not I know the value of the die is greater than 3 does not change whether or not I roll doubles. So these are independent events because this is also equal to the probability of A. So now, let's find the probability of B given A. So, knowing that I've rolled doubles, what is the probability that die 1 is more than 3? Okay, so now my sample space, again, is reduced. I know that I've rolled doubles. So that's this main diagonal right here. Now, how many of these has die 1 with a value greater than 3? So again, there's 1, 2, 3, 4, 5, 6 values along the main diagonal. 3 of them have a die 1 greater than 3. So this would be 3 out of 6. Which again, if we compare that to the probability of B, that is 1/2. And so these are independent events. Now looking forward to the probability of A given C. So here, we're looking for the probability that we roll doubles, given that the sum of the dice is even. So I'm going to look back at my sample space here. My sample space has been reduced. I'm going to highlight this time. So my sample space is just these values here, okay? So I've essentially cut my sample space in half, and we found that there were 18 of those values before. So my sample space is now 18, been cut in half, and we're looking for the probability that I rolled doubles. And so it looks like all of my doubles are even here. So my doubles are here. So I still have 1, 2, 3, 4, 5, 6 doubles out of the 18. So this is 6 out of 18. Now, that is 1/3. Or no, that's not 1/3. It's 6 out of 18, which is 3/9. Okay? 1/3. That's what I said. 1/3. Yeah, 1/3. And so that is not equal to 1/6. This is not equal to the probability of A. And so these are dependent events. So the A and C are dependent on one another in this scenario. So now let's find the probability of C given B. So we're looking for the probability that the sum of the dice is even, given that die 1 is more than die 3. So again, we're looking for die 1 being greater than die 1 being greater than 3 is this sample space right here. And now we're just looking for the sum of them being even. So there's 2, 3, 4, 5, 6, 7, 8, 9 values in here. 9 values out of the 18. That were highlighted in that region, which is equal to 1/2. And that is the probability that C happened. And so these are independent events. And then finally, we have the probability of B given C. And so now we're looking for the probability that the die 1 is more than 3, given that the sum of the dice is even. So now my sample space is the highlighted region, and now we're looking for all the values where die 1 is greater than 3. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 18 that was total. So again, this is going to be 9 out of 18. The probability of B was also 1/2, so these are independent events. So the only dependent event here ended up being this one, probability that we roll doubles given that the sum of the dice is even. All right, well, I will see you in the next video. Have a good one.